Assalamualaikum warahmatullahi wabarakatuh, and good evening and good afternoon to everyone watching this tutorial on how to make a geomorphological map using an ArcGIS software. So today we are a group from the group number 13 from the course of Geoscience of University Malaysia Kelantan. Here we are going to present to you on how to prepare a geomorphological map with a scale of 1 to 25,000. Here we are going to show you the zonation of different types of landscapes, including but not limited to structural geology, which is identified to be, there you can see in the background, metamorphic, metamorphic, and then sedimentary rock from our study area. Here we also use the satellite imaging obtained from the Google Earth software, which we use to confirm the interpreted map, and ArcGIS software to be as accurate as possible to produce a high quality map and a very detailed one at that. And moving on to our team members, from the top left, there is me, Muhammad Shahmi, as the team lead, and then there are Afham, Izzat, Xavier, and Shahrul Izwan. We are from the same group that underwent the field trip to Bukit Bucu in Kuala Terengganu to conduct a field site analysis for our both subject, which is right there is geomorphology and paleontology. And right here we are going to present to you the data we collected has been transformed into a very detailed geomorphological map.
Greetings, my name is Xavier Walter and my matrix number is E23B2696. The first step of making a geomorphological map is digitizing. Digitizing is the conversion of geographical features into digital format for ease of analysis and visualization. In this presentation, we have chosen Bukit Bucu as our area of study. To begin, we launch ArcMap 10.8, which is a geographical information software. Once launched, we create a new blank project. Next, we select the imagery with labels option as the base map. This option was chosen because it provides a clear satellite view of the area complete with labels. Using the magnifying tools, we zoom in to the study area for a closer look. The next step of the digitizing process is saving it as a shapefile. A shapefile is a geospatial format that supports the creation of geometric features, such as polygon. Shapefile also ensures that the digitized data can be stored and edited for future use. After that, we activate the polygon line tools, which allows us to draw the boundaries of geomorphological features of the study area. The features includes forests and bodies of water. The features were then assigned colors. The forests were colored green, while bodies of water are colors of blue. This color coding is for the ease of analysis and aesthetics. These processes are important and will affect the end result of the geomorphological map produced. So, it's important to keep in mind that the accuracy of the polygon line is key.
Hi, my name is Muhammad Afam Firas bin Masbadi, number matric E23A2838. Okay. In addition to forests and bodies of water, outcrop rock types were also digitized. This is important because the outcrop present allow us to better analyze the morphology of the study area for various purposes such as environmental assessment. Using the same process, areas of metamorphic rock were colored to be brown. Areas of parametamorphic rock were colored light brown, and areas of sedimentary rocks are orange. Using three color make the map visually informative as well as aesthetic. This could also help to analyze spatial relationship between geological features and other elements like the previously digitized forests and bodies of water. In the conclusion of rock types functions as an assessment for the suitability of construction, agriculture, or environmental conservation. Addition, it could help with geohazard assessment. For example, areas with limestone has a high potential for sinkhole to form during monsoon season. Knowing this, we could help prepare an evacuation map for the residents nearby. Thank you.
3. Digitizing of residential area. In continuation of digitizing outcrops based on generalized rock type, it is equally important to digitize man-made structures and features such as residential areas, which include houses and parking spaces. It's important to do so because it gives context to how human and nature interact with each other. Using the same method, the residential areas were also digitized using the polygon tool. In the residential area, the houses, specifically the terrace houses, were color-coded to be red. Red was chosen as it is high contrast color as compared to the rest of the map. Alongside the houses, the parking space near the houses were also coded and if chosen to be grey color as to reflect what is represent. That being said, the presence of housing and parking space reflects that the area has active human activity. By making this geomorphological map, we could assess how far a body of water or look for potential water sources for the benefit of the people in the area. Another importance of digitizing residential area is to access geohazard area. In this case, Taman Atika, which is Bukit Bucu, is surrounded by moderate hills and is located 450 meters from a coastline. By making a geomorphological map, we could easily analyze these hazards and prepare an evacuation plan. In summary, digitizing residential area gives better context for a geomorphological map by highlighting the connection humans have with their surrounding area.
Once the map was completed, it was carefully analyzed to interpret the key features of the landscape. The forest areas, marked in green colors, were mostly concentrated in the higher elevations of Bukit Bucu Terengganu, indicating a natural, undisturbed environment. House area, represented in pink colors, were found in the flattest regions, which are more suitable for urban development. The water bodies, marked in blue colors, were located in low-lying areas. The map also showed the distributions of geological zones, highlight the areas of sedimentary, metamorphic, and parametamorphic rocks. The final geomorphological map of Bukit Bucu Terengganu provide valuable insights into the region's landscape, illustrating how different landforms, geological features, and human activities are interrelated. The map can be used for various purposes, including urban planning, environmental management, and geological research. The joining of different geomorphological and geological units will help decision makers in Terengganu better understand the suitable of area for development, conservation, and other land use.
Moving on to the final step, here we are going to add the contour lines to our map. How do we find contour lines? Well, usually we import the contour lines from the data obtained from the field site analysis or even an open source data file where we usually get from the internet. And here we try to import a general data from the internet about the altitude in Malaysia. But unfortunately, as you can see, our study region is too small for the data and is therefore engulfed by the darkness of the gradient of the data, which means that the altitude is too generally too average low that it cannot form a particular slope or contour lines. And for that matter, we cannot use this method. And unfortunately, after much hours of discussing, learning, watching tutorials, we therefore have decided that we can also make our own contour lines. But of course, we must do it accurately. And how do we achieve that? Well, there are two ways to ensure the data is stay accurate and integrity. The first one is by referencing it to the Google Earth software, where there are small contour lines around the Bukit Bucu area. So we can use that as our reference. And second, we can use the data that we obtained from our field trip, where we collected the coordinate, the compass meter, and we collect our own data of elevation from the sea level. And by that, we can determine which mountain has the same elevation, and by that we use the new shapefile and set it as a polyline, and then we trace the line of each mountain ridges, the hill ridges, and then here you can see there are already 6 or 5 polylines, which determines that the contour lines we have achieved here ranges from the elevation of 80 meters until 24 meters above sea level. This is because we have already determined the elevation which is required when we are searching for the fossil and the fossil site which is abundant of fossil assemblage. And here you can see after much careful plotting and determining referencing the polyline, we finally have a very much suitable contour line to be used for the geomorphological map. And here you can see we have to select a few particular set of contour line to label them up because it is the standard of creating an ArcGIS map. When we are adding a contour line, there are not a perfect solution to label each of them. The standard usually set every 5 interval of contour line, we set them, one of them has label the elevation value. But here, because the area we study is too small, we set it at two to once per 2 intervals. And unfortunately, as you can see here, the footage skip into the final phase of the project and skip the whole progress of layout view because unfortunately due to data error and video corruption, which we already tried twice to accomplish and overcome, but unfortunately it failed horribly. And here I can still explain to you, here we added a second data frame because our study region is too small for the rubric or the assignment requirement, which is require a scale of map to be 1 to 25,000. Here, the data frame of our study region is only 1 to something around 100 units because here we are 1 centimeter to 0.01 kilometer. And the second data frame you can see on the right side is the perfect required scale frame, which is 1 to 25,000. So according to the standard of ArcGIS, this is usually acceptable, which is not a very uncommon practice, but can be used to fulfill the needed requirements. And then you can see the legend, which is we saw earlier from the footage of the first layout, which utterly failed because it does not fulfill the requirement. And then we also added the usual standard north arrow, and then the standard title. And then we also added a little text on the bottom right, which specified what kind of coordinate system we use and who prepared this marvelous map, which of course is us. Okay, I think that's all from me. Thank you. That's all. That's all from us. That's all from us. Thank you very much for watching. Thank you everyone, our viewers, and thank you for Dr. N for your generous attention to our project and our presentation. We are very much apologize. We are very sorry due to our mistake. There are a couple of errors, a couple of mistakes, missing recording and footage of the tutorial, and we are hereby vow to more improve ourselves more in the future and avoid such circumstances, and hopefully able to produce such tutorial or such guide to help further newcomers that are going to need it. That's all. Thank you very much. I hope you all have a very nice day. Assalamualaikum warahmatullahi wabarakatuh.